last question is for which one? Will you use or the kinematic equation? That's physics one. There is that one thing here that like
So does anybody have any concern on the quiz or anything? So most of
he didn't teach me.
who like some people, like some students send me emails, they said like they didn't find the quiz idea in any of the lectures, but I give you the whole idea of the lecture. Okay? So the quizzes are meant to be for the students who are attending the lecture. So focus on the lecture, and the quiz problems idea might be direct, might be indirect. So if you focus on the lecture, the quizzes idea, the 25% of all the grading will be based on the lecture. That's why I'm not taking attendance. Because who's attending the lecture is gonna know how to solve the quiz. Okay? So try to focus as much as you can. All right, so today we are gonna end the chapter 12. We will talk about we will end the curvilinear motion. So curvilinear motion, we did Cartesian, we did tangent normal. So today we are gonna do polar coordinate system. So yeah.
Are we going to do relative independent motion?
No, we're not gonna do that.
Okay.
Yeah.
What edition are you using for the book exam?
What was that?
What edition of the book are you using for your exam?
Oh, well, right now I'm using 14, but 14 from 15 is not that big difference.
I'm just asking because on the homework you refer to
Teaching grade,
after 15 it doesn't.
Yeah.
Well,
So that's why I'm kind of
I think I'm using 14, but I might double check the homework.
because I got the like the actual number right. Teaching grade is
Different version.
like the file.
The file, like everybody has check your
Oh,
So that's why I have file.
well, I'm gonna upload the model answer for the homework. So once you submit it, I'm gonna upload the exam. We have a TA. I'm gonna introduce him. He's gonna grade the homework, grade the quizzes. So I might introduce him to you. So if you have any questions about the grading and everything, okay? So let's just start with curvilinear motion for polar curvilinear motion. And right now we are gonna do polar coordinate system. So we have R and theta. If you guys remember from last time, we used curvilinear motion if a body's moving on a curve. So last time we had like an x-axis and y-axis. And if we have a curve like this, and we have a body is moving on this curve like something like this, and it's away from the origin, something like that. What we did last time, we did tangent normal. So we said that the tangent is always in the direction of the velocity and tangent to the curve, something like this. And the normal is perpendicular in which direction? This direction or this direction?
Left.
In the direction of the radius, something like this. So this was tangent and this is normal and this was perpendicular, okay? Right now we are gonna do different coordinate system, which is gonna help us with some types of problems. Let's see what is that. So the new coordinate system say that we are gonna use not tangent and normal, we are gonna use R and theta. So if you wanna know the direction of R, so you need to have a center. Let's assume that this is the center of the motion. And then the R, the position is something like this. This is R, R vector, and this is theta. Okay, so this is how you describe the motion. If it's here, it's gonna have different R and different theta. But let's see what is the direction of R and theta. So the direction of the R vector is the same direction. Let's just spell it for you. It's the radial axis goes from the origin through the particle. So we have here is the origin and here is the particle. So the direction is this way. So this is the R direction, the R vector. Okay? And we call like the unit one is UR. So the unit vector. And the theta is perpendicular to the R. Okay, if I said that theta is perpendicular to the R, so there's two options. It's either goes this way or down. So it says in the direction of the increasing theta. So if theta is increasing this way, so theta is perpendicular to the r this way. So this is the theta vector. Okay. So we are right now dealing with a new coordinate system, r and theta. So right now when I give you a problem, the first thing that you need to draw is the direction of r and theta. So as you know, like if the particle is moving this way, so r is from the origin to the particle this way, and theta is in the direction of increasing theta, and both of them are perpendicular to each other. All right? Okay, so let's do the same thing that we did for every coordinate system. Number one is the position. How we can describe a position in a polar coordinate system. So r vector has only one component in the r direction. So it has r value in the direction of the r hat, or u r hat, plus 0 in the direction of u theta hat. So this is the r vector. The whole vector is in the same direction of r. It doesn't have a component in the theta direction. Okay? So it has the full magnitude in the direction of r and 0 in the direction of theta. Alright, so the v vector, as we know, the v is always tangent to the base, whatever the coordinate system is. Like always v is in this direction. So this is the velocity. And it happens to be in the tangent normal. Based on the coordinate system, all v is in the tangent direction, right? But right now we have different coordinate systems. Rather having a tangent and normal, we have r and theta. So v will always have a component in r and a component in theta. So we definitely having a component v in the direction of r and v theta in the direction of u theta. Same thing, the acceleration is going to have an acceleration r in the direction of u r hat plus a theta in the direction of u theta hat. Okay? Right, but let's find out how we can get r is very direct. It's the magnitude of the radius in the direction of u r and 0 in u theta. So let's find the velocity. So let's get number 2. I'm not going to write here because you guys don't see this part, so I'm going to write here velocity. So the velocity, what is the definition of velocity? Somebody know what is the definition of the time rate of the change of the position? So what I want to do with r, take the first derivative, right? So the velocity vector is the time rate of the change. When I say time rate of the change, so it's the first derivative with respect to the time, to the position r. So let's take the first derivative of r. So I know that this part is 0. So I will not care about the theta component. This one is out of the calculation. So I have two components. I have r and I have ur hat. And some of you are going to say, okay, how about I only differentiate r because ur hat is 1, so I don't care about it. It's just 1. No, it's a direction, and this direction keep it changing while the particle is moving with the mass. The r hat, like this is the r hat, something like this. Sometimes we call it ur hat, and this is the u theta hat. It's a unit vector in the direction of r. If it's here, it's gonna have different direction, but it's the same magnitude, 1. So you have r is a changing in magnitude and direction. So if I want to differentiate, so both of them are variables. So to differentiate two variables, what should I do? The derivative of the first multiplied by the second plus the derivative of the second multiplied by the first. So this is going to be the derivative of r dr dt multiplied by the second ur hat plus the verse, which is r multiplied by dur hat dt. Does anybody have any problem with that? 2x and y, you want to differentiate them with time. So it's going to be dx dt multiplied by y plus x multiplied by dy dt. Okay, so dr dt, we can write it as r dot, the time rate of the change of r, multiplied by ur hat. This one is r multiplied by this value. If you guys remember, we did a long derivation to find the value of dut dt, like we had something, like for example, something like this, tangent normal, and then we had the tangent hat and normal hat, and we had the theta, and then we tried to find some values, and we came up with, like for the tangent normal, we are gonna do the same thing with dur hat dt. And you will find the derivation here in the notes. I'm not gonna do it again. So I'm gonna say that dur hat dt is gonna be equal to theta dot u theta hat, and du theta hat dt is gonna be equal negative theta dot ur hat. If you don't remember this, go back to the last lecture, and I'm having the derivation one more time here. So I'm gonna remove dur hat dt, and I'm gonna put this value. It's gonna be r theta dot in the direction of u theta hat. So this is the velocity, and this component we call it vr, and this component we call it v theta. All right. The second part is the acceleration. Number 3. What is the definition of the acceleration? Is the time rate of the change of the velocity, right? So I'm going to do the same thing. The acceleration vector is the time rate of the change of the velocity vector dt. So right now it gets bigger. I have two terms. I need to differentiate them with respect to the time. And one of them has 3 variables. The other one has 2 variables. Okay, I need you to differentiate with me. This part first. Let's do it. I'm going to differentiate this 2, but I'm going to start with this one. What is the derivative of this term? The derivative of the first multiplied by the second plus the derivative of the second multiplied by the first. So this is going to be r double dot multiplied by ur hat as it is, plus the first r dot multiplied by the derivative of dur hat dt. So I'm done with the first part. Let's get to the second term. This is 3 components. What I'm going to do, how to get the derivative of these 3 variables. Same thing, the derivative of the first multiplied by these 2, and then the derivative of the second multiplied by these 2, and the derivative of the third multiplied by these 2. And if they are 4 variables, you are going to do the same thing. You guys remember this in the differentiation? Have you guys solved problems with 3 variables derivative? Not before?
I remember.
Okay, so let's put this here. If you have a function in x and y and z up to n, okay? So and this function is something like x, y, z, whatever variables that you have. And you want to differentiate this function with respect to any variable, let's say t. So it's going to be the derivative of the first, dx dt, multiplied by all the terms here. Y, z, of all the terms, plus the derivative of the second, dy dt, multiplied by all the terms non-differentiated. So we are going to lift it with x, z, with all the terms, plus the derivative of the third, dz dt, plus x, y, with all the terms. And you keep differentiating until you end to the last term. So you differentiate one term at a time and multiply by the other terms non-differentiated. Did you guys got that? And that's what I did here. So I have 2 components. I differentiated that and multiplied by this one. And then I came to this one and multiplied by this one. I have right now 3. So you guys tell me, how can I do this one? Which will be r dot, right? Multiplied by u theta hat. Then plus r as it is, and this one is going to be theta, double dot u theta hat, plus r theta dot du theta hat dt, right? Okay. I said that you guys know that. Sorry about that. Okay. So let's remove these terms. I have dur dt is equal to theta dot u theta hat, this one. And I have this term is equal to theta dot u r hat. So let's do variable separation. Let's separate the variables and make all the variables that has u r hat in one parenthesis and the one that has u theta hat in one parenthesis. So this is gonna be who that has u r. I have this term has u r and this term has u r hat. Okay, so both of them share u r hat. So this is gonna be r double dot plus theta dot multiplied by theta dot. So this is r theta dot squared. All this is gonna be u r hat plus the terms that has u theta hat is this one. So you have r dot theta dot and you have another one r dot theta dot. So it's two of them. And then you have r theta double dot. So you have r theta double dot plus 2 r dot theta dot, and all of them have u theta hat. Okay? So right now I drive the velocity and I drive the acceleration. And all these equations are in the equations sheet. Okay? So all I care about this one and this one. Alright, one last tip. Sometimes we can convert this from 2D to be 3D. But I'm not going to give you a 3D, but I'm going to give you an idea how, if it's a 3D, it's going to look like. So let's assume that we have, this is our 2D, and this is X, Y, and this is Z, right? And we have a point that is moving in the 3D like something here, and this is actually the direction of increasing theta, and this is R, and our point is something like here, okay? So this is UZ hat, and this is the direction of UR, because R is this way, so R is gonna be something like this, UR. And the theta, the direction of increasing theta, so it's perpendicular to this one, so it's gonna be u theta, and it's in the direction of increasing theta. So it's gonna be something like this, and the body's moving in the 3D. And all what is gonna change is that we are gonna add a new term here. For example, where's R? So rather than having this one, we're gonna have like something is called Z, uz hat. And the velocity, you are gonna have plus z dot, because it's a linear, uz hat, and this is plus z double dot uz hat. That's the only change. But we're gonna have that. So let's assume that this doesn't exist. All the application that we have in this class is 2D. But if it's a cylindrical motion, like you have a body, you guys, I don't know, like there's slides that are spiral, and the body is moving in a polar coordinate system that is changing with z. So if I told you that this body is moving down in the z direction with a speed down like 2 meters per second, so the 2 meters per second is gonna be the z double dot, and the acceleration 2 meters per second squared, so it's gonna be the z double dot. Okay, so this is just for your reference. Okay, so let's solve a quick example. All right, this is example 12, 17 in the textbook. So it says that there's an amusement park that has a circular shape, something like this. And the bar chart shown in the figure consists of a chair that is rotating in a horizontal circle that was radius r. So there's a chair here moving in a horizontal circle, and radius has a radius r, such that the arm OB, so this is the arm OB, has an angular velocity. This is the direction of increasing theta, and giving to you the theta dot, because he doesn't say theta dot, but he said angular velocity. So when I say angular velocity, so it's theta dot, and it's equal to, oh, she doesn't get theta dot actually. You just say that it has an angular velocity theta dot and angular acceleration theta double dot. Determine the radial and transverse components of the velocity and the acceleration of the vessel. Okay, so since everything is a variable, so I'm asking you to get the velocity and acceleration as a variable. Okay, so what is special about this? When you're given a circle and the center of the motion is the center of the circle, so r is always constant, right? Because r of the circle is always constant, but this one is not a circle. It's a general curve, and this is the center, and r keeps changing as the body's moving. So the special about this is r equal constant. So r dot is equal to, if r is constant, I differentiate it, 0, and r double dot is going to be 0. So if I substitute here, I'm going to have r vector is r in the direction of ur hat. How about the velocity vector? This is the velocity vector. It's r dot multiple plus in the ur hat plus r theta dot u theta. So this one is equal to 0, so it doesn't have a component in the ur and has only component in the v theta direction. So velocity is going to be r theta dot in the direction of u theta. How about the acceleration? So r double dot is 0, so I'm going to lift out with this component. R dot is 0, so I'm going to lift out with this component. So you guys tell me the two components. It's going to be r double dot in the direction of ur plus, what is the other component? If I put r dot is 0, so I'd be left out with r theta double dot in the direction of u theta. And actually that's all what is required from this problem. Alright? And actually that makes sense. Like, let's give it a look. We always have v as tangential. So if we want to lay out,
I thought r double dot was 0. On acceleration.
oh, sorry.
Yeah.
I put, this should be, sorry, yeah, r theta dot squared. Perfect. Excellent. R theta dot is squared. So this is the only component. So this one is going to be 0. So usually you cross that so that you don't miss out which one that you should put. So r theta dot squared. But let's see how's the vectors look like. If I went to lay out the r theta vector, so this is the r direction, right? Because it's in the direction of r. How about theta? Is it this way or this way?
Oh, when you distribute something.
Down or up?
Down.
Down, right? This is the direction of increasing theta. So this would start from here and increase from here. So this is the increasing theta. And if the body is moving in this circle, and velocity, as we know, it's always tangential. So it's always tangent to the curve. So all the velocity is going to be in the same direction of theta and doesn't have any components in r. And actually that makes sense. It has r theta dot u theta, doesn't have component in the r direction. How about the acceleration? It has a component in r, this way, but, oh, actually we have something that maybe we didn't take care of here. I think the sign, okay, so this has sign negative. We missed one negative here. Okay. Theta dot. Okay. Just one moment. Yeah, and okay, let's take step by step. So differentiate this. It's gonna be r theta dot. So this is positive, and this is r theta double dot multiplied by u theta, and this is negative. So this is gonna be do it one more time. I told you how did I figure this out. Right, so let's do it. So here r theta, r dot theta dot, so you have this is positive, and then you have this one, r theta double dot. Yeah. Yeah, it's supposed to be.
So instead
So
of
this
plus,
one
it should be negative.
is negative. This one is right. Yeah. So this is the only thing that is negative because this is negative, and this one was right. R theta dot.
Okay, it worked, fine. And then you can try it with it.
R theta dot R. This is U R. So R dot theta dot R dot theta dot. So this is 2. So this is R theta double dot plus 2 R dot theta dot. Let's double check. Yeah, that's true. So the only one that is negative is this one. How did I know that there's something wrong here? Okay, because right now, let's see how did I figure it out. If I said that r theta dot square is positive, so that means that the acceleration normal is going this way, not in the direction of the curve, and actually that doesn't make sense. If a body needs to be on a curve, the acceleration needs to go to the center. If it's out of the center, this body is going to leave the curve. So when this was positive in the direction of r, it triggers something. It needs to be negative. So this one should be negative, and this is going to leave this negative sign here, so that the one in the direction of r needs to be going to the center. All right. So this is actually the solution for this problem. So let's solve another one.
What's the right equation? For acceleration?
No, this is it's just a sign in the parentheses.
Okay, usually the problems is gonna be just to be systemized when you solve like curvilinear motion problems. I'm gonna give you r as a function of theta, or theta as a function of r. The first thing that you do when I give you an equation, so you differentiate it one time and you differentiate it second time to get r dot and r double dot, so you can substitute here. So don't think, like if you don't know how to solve the problem and you are given an equation, r function in theta or theta function in r, differentiate it once, differentiate it twice, because both equations have r dot, r double dot, theta, theta dot, theta double dot. So you differentiate it, you will be able to put like, I give you the equation, you differentiate it twice, and you look in your equation sheet, you will find the equation of the acceleration, the equation of the velocity, and substitute in them. That's it. But first you have to understand the problem, how it's work, where is r, where is theta. Like the problem can be a little bit complicated. Like when you think about curvilinear motion with r, so usually it's like when it moves on a circle, like the body's moving in a circular motion. So like for example, if I have a bar like this, and this bar is rotating around this disc, and it has a shaft here, like this is an empty, like this one, and you have like something is moving here, like a nut or something that is moving on a bar, something like this, and it's connected here to this center. Okay, so let's see how this particle is moving. You have this arm can move this way, okay, and you have this nut can move this way. So you have two things is moving. This one is changing. And why did I give you this? because this part is a changing in theta, so this one, theta is keep it changing, and this one is responsible for changing r. So that's how we can make r and theta is a changing over time. Okay? So if this part is moving this way, so that means that theta is a changing. But if this particle is moving this way, so that means that r is a changing for this part. But if this one is not moving, so r is constant. Like if this particle here is maintaining the same position, so that means r is constant, r dot is 0, r double dot is 0. Okay? But I'm giving it this way, that means like I can move this particle here and there so that we can change r. So let's see how is the rate of a change of r and theta look like. So I'm giving you in this problem, at this instant, theta equal to 120 degrees, and I give you also the theta dot is equal to 0.1 radian per second. So I might give you in a quiz the same problem, but I don't give you theta dot, but I give you function for theta dot, and then, like for example, let's say that I give you theta dot is equal to something like 2 sine 2r. Okay? So what you are going to do, or 2 sine 2 theta. And I give you theta is 120 degrees. So what you are going to do is going to substitute here and get the value of theta dot. And when I ask you for theta double dot, you will just differentiate this equation. So it's going to be 2 cosine 2 theta, right? Multiplied by the differentiation of this one. Okay, let's make sure that you also know this part. How can I differentiate this with respect to the time? Like, let's say that I have a function y equal to 2 sine 2x. And I want to differentiate this with respect to x. Like, I want to differentiate this d dx. It's going to be? It's going to be, first, let's do it step by step. 2 is going to be 2. Sine is going to be cosine. 2x, and the differentiation of what is inside. The differentiation of 2x with respect to x is going to be 2. So 2 multiplied by sine 2x, sorry. The differentiation of the sine is cosine. 2x multiplied by 2. But let's differentiate this with respect to the time. Another way, how this is going to be, dy dt is going to be equal, same thing, 2 cosine 2x, and the differentiation of what is inside with respect to the time is going to be 2 multiplied by dx dt, right? Because this one I differentiated is going to be, what I did here was 2 multiplied by dx dx. So the differentiation of x with respect to x is 1. So that's why this is equal to 1. But here, the differentiation of x with respect to the time is not 1. It's the velocity in x direction, okay? Same thing if I want to do it here. Like if I want to differentiate this, it's going to be 2 sine, and this is going to be 2 theta, multiplied by the derivative of what is inside with respect to the time, because dot is always time. Like this is d dt. So this is going to be 2 d theta dt. Did you guys got that?
Yeah.
All right. But here I give you directly theta double dot is equal to negative 0.04 radian per second squared. And I also give you r, the time rate of change, how this is changing its position. So r is a function of theta, and this is 2 sine theta. So let's guys do it. First, we need to calculate r, and we need to calculate r dot and r double dot. So r, the radius at theta equal 120 degrees is going to be 2 sine 120. You guys tell me what is the value of this. If I want to get r dot, I need to differentiate this with respect to the time. d dt, you guys tell me what is the value here based on what I did here. 2 sine theta. If I differentiate sine, it's going to be cosine theta multiplied by perfect. which is theta dot. So it's 2 cosine theta multiplied by theta dot. So if I want to substitute to get r dot at theta equal 120 degrees, it's going to be equal to 2 cosine 120 multiplied by theta dot at 120, which is given here point 1. And I can get this one. If I want to get r double dot, I want to take another derivative with respect to the time. So right now I need to take the derivative of this. This has right now 2 components, cosine theta and theta dot. Do you guys remember the rules that I put here? It's 2 variables. I'm going to differentiate this part multiplied by this part, and this part multiplied by this part. So it's going to be, let's differentiate this part. It's going to be, if I differentiate 2 cosine theta with respect to the time, it's going to be perfect. -2 sine theta multiplied by the derivative of what is inside, which is d theta dt, which is theta dot, right? And I already have another theta dot here, so this is going to be theta dot squared. Does anybody have any questions? So what I did here, this part is the derivative of this part, and then I multiply by this part, so this is going to be squared, plus this part, as it is non-differentiated, multiplied by the derivative of this with respect to the time is going to be theta double dot. Does any of you have any question? I can repeat it if you don't get it. Okay, so I have r dot, let's say r is r2 sine theta. It's only one variable, which is sine theta. When I differentiate it with respect to the time, so it's going to be 2 cosine theta multiplied by the derivative of theta d theta dt to give you theta dot. Right now, when I differentiate it one more time, so this is a variable, let's say x, and this is another variable y. So if I want to differentiate it, let's get back to this. X, Y, Z. You differentiate first one multiplied by all the variables. Differentiate the second one by all the variables. That's what I did here. I differentiated cosine theta. It gave me -2 sine theta multiplied by theta dot. And then I multiply by this one, theta dot. So when you multiply theta dot by theta dot, it's going to be theta dot squared. And I do differentiate this one and multiply by this one. So it's going to be 2 cosine theta as it is, multiplied by the derivative of this one. So theta dot, when you differentiate it one more time, is going to be theta double dot. Then you substitute. Does anybody have any question? R double dot and theta equal 120. So you substitute with all these values. So you are going to have R is going to be 1.73. R dot is going to be -0.01. R double dot is going to be 0.007. Okay? And substitute with all these values. So the next part is, why did I do that? That's the step that I told you about. You will be given R as a function of theta and theta as a function of R. So the first thing that you did in this problem is to get the first derivative and the second derivative, theta dot and theta double dot. And you were lucky here that this was given in the problem. But here I give you R. So you differentiate R to get R dot and differentiate one more time to get R dot. So right now you are preparing your problem to solve it. How? Because what I want from this problem? I want to get V, and I want to get A. So V is R dot in the direction of QR, and I have R dot here, so it's a -0.01 here in the direction of QR hat, plus R multiplied by theta dot. So I have R is 1.73 multiplied by theta dot, which is 0.1, so it's going to be 0.173. U theta hat. A is a component, these 2 components, R double dot minus R theta dot, so you will do the math. You have R double dot, it's here, 0.0027. You have R is 1.73. You have theta dot, so you will do some math, and you will get this as 0.054 in the UR hat. And you will do the same thing for the theta hat divergence, so it's gonna be 0.0892 in the U theta hat. Does anybody have any questions so far? Again, in the curvilinear motion, it's the first step is to get the derivatives of theta and the derivatives of r. Because to get velocity and acceleration, they are all function in r dot, r double dot. Theta, theta dot, theta double dot. So you should know how to get the derivatives of the sine and cosine. I'm not gonna go crazy with the trigonometry, like I'm not gonna ask you for tan theta, sec theta, and all these stuff. So usually sine and cosine, okay? Maybe the exponential, because it's easy. Like if you have e to the power x, you differentiate it, it's gonna be e to the power x, okay? So that's the stuff that I'm gonna ask for, and I believe you already have the sheet to check on them. Once you get these values, you substitute in the acceleration and the velocity equation.
I think that line just means that it's plugging in.
I solved another problem in the notes. It will be one of the problems in the textbook, like non-solved problems. You just check it, you will find that the only difference is that I give you that theta dot as a function of time with exponential, like theta dot is equal to e to the power 0.5t squared. So you need to differentiate it to get the acceleration, and you need to integrate it to get theta. Okay, so just to check this problem. So we are going to move to a different topic today in the 30 minutes that we have here. It's much simpler from my perspective than the linear and curvilinear motion. It's called dependent motion analysis, chapter 12.9, dependent motion analysis. Okay? So the dependent motion analysis is related to the connected particles that moves together. Like for example, you can have like surface like this, and you have a block here, and a block here is moving on this surface, and somehow there's a pulley rested here, and there's a wire or a cord that connect these two together. So this is part, like this is mass A and this is mass B. So what happens is, we call this as a dependent system. How? Like if this one is moving this way, so definitely this one is moving where? Up, right? So they are dependent. If this one goes down, this one goes up, and the velocity of this particle controls the velocity of this particle. So we call this dependent motion. So let's just give you an example, a very quick one. How can we solve these problems? Okay, so we have so we have a system pulley, and they are connected with one cord. This cord is something like this, connected to the center of this body, and move all the way up here, and it goes down to the way here. They're supposed to be under each other. Like let's make them. We're gonna draw a lot today. is something like this. And going down until somewhere here, and then we have another solid here, and then still goes around here, and then goes up something like this. So what we want to study is, like, if you have another body connected here, let's say that this is A and this is B, right? And for example, you know that VA is moving up with a velocity equal to 1 meter per second. How can we get VB? All right, so what we know the dynamics of the motion, we know how to relate velocity with distance, right? That's a dynamics thing. But we also know that the length of this cord is constant, right? Like if you roll this down, the rod or the cord is gonna stay the same length, okay? So let's first determine what is the moving part. The first thing to determine what is moving, you need to have a datum, like datum that doesn't move. So I know from here, all these parts doesn't move, like this doesn't change in length. And this part doesn't change in length, and this part doesn't change in length. What it changes in length if this goes down, this length, and these lenses from here to here, because this cord can go up, so it's gonna change these, and all the rope is gonna go down, but this is gonna stay the same. So I know that this body, like if I have that this is as a datum, I know that this body is at this position at distance YB, and this body or this pulley is at distance, for example, YA. So let's count, let's see what is the rod length. Assuming that, for example, this piece has a length x1, and this piece has a length x2, and this piece has a length x3, and this piece has a length of x4. Okay? So the length of the cord is going to be equal to, let's just start from here. You guys tell me, what is the length of the red cord? YB plus x, let's just start here, x4 plus x3 plus x2, right? x4 plus x3 plus x2 plus this length, which is YA. Sorry, I forgot to give you this part is going to be, for example, x5, right? So x2, and then you have YA and another YA, so 2YA plus x5 plus x1, right? So this is the length of the rope. I just put the pieces together. YB, x4, x3, x2, YA, x5, another YA, and then x1, okay? And I know that this length is constant. We're gonna use this, y is constant. I could have written this as YB plus 2YA having a constant value. Why? Because I know that this part and this part and this part and this is small part and this is small part is not changing. It's always the same. Okay? But what is it changing? It's these two parts and this one part. They keep it changing. And once they're changing, but they get each other. Like if this one got shorter, this one is gonna get longer. So what you lose in length here, you get it here. What you lose in length here, you get it here. So for example, what happened, let's assume that this is going up. How about B? Where is it gonna go? Down, right? How? Because all these two is gonna give double length to this one. And that's what we are talking about here. YB plus 2YA is always equal to constant. So what you are gonna do, you need to figure out how many chords you have in your problem. Sometimes you have two chords. Here I have only one chord. And then you find out where is the moving parts. And the constant parts, you can exclude them, or you can have them, but you are gonna make your problem much longer. It's much easier for me to write that the moving parts is equal to constant, right? better than writing the whole length of the entire chord. Okay? So since yb plus 2ya is equal constant, so if I take the time derivative of all this equation, d dt, is gonna be dyb dt plus 2 dya dt, and when I differentiate the constant, it's gonna be 0. If you did the same thing with this equation, it's gonna be the same thing. You differentiate yb, dyb dt, but when you differentiate x4, this part is gonna be 0 because x4 is constant, and x3 is constant. This part, if this particle came here, this one is not gonna change in length because it's a fixed length between these two. And the length here is the fixed length. It's not gonna change. So you will end up with having that the velocity at B plus the two velocities at A is equal to 0. So the velocity at B is equal to negative 2VA. So if VA is 1 meter per second, but keep thinking to the direction. I assume that YA is down, but the velocity is given is up. So VA is negative because my assumption is going down. So I say here that VA is negative 1 meter per second because it's going up and YA is going down. So VB is going to be negative 2 multiplied by negative 1 is going to be 2 meter per second, and it's going up, not up, sorry, it's positive. Let's see where is the positive direction. The positive direction is up or down. YB, I said down, okay? So 2 meter per second doesn't mean it's going up. It means in the same direction of the assumed direction. So YB is down, so VB, positive, is down 2 meter per second. And this makes sense. Why? Because if VA is going 1 meter per second up, so you have one from here and one piece from here, right? And these two is going to add 2 pieces here. So it's going to be 2 meter per second going down. Does anybody have any question?
Velocity, when you do another assumption, you have at the beginning.
Assumption? Oh, this one?
Like the velocities you didn't get at the beginning. You just put it
This
at-
is given in the problem.
Okay.
That V, I will definitely give you the velocity of one body so that you can get the velocities of other body.
I understand when finding the velocity that the constant, when you derive it, turns into 0. But as far as with the length, how can you write a YB plus 2YA is equal to C? What happens to all the other constants?
Okay, so, well, I either can write that the
Yeah,
total
the
length,
not the velocity.
I can write that the total length is equal to these things, okay? But I know that the length is constant, right? It's not gonna change.
Yeah.
And I know that x4 and x3 and x2 and x5 and x1 are constants, right? So if I put all these constants and send them the other side, which is a constant, so YB plus 2YA is gonna be constant. But I can't say that YB plus YA is equal to L. Like I can't say that because YB and Y and 2YA is a part of the length, not
Yeah.
whole of it. So that's why I removed this and I put a constant. But like, how did I do it? Because I know that the length is constant. Let's say it's 10. And this one is 1, 2, 4, 5, whatever. 3. So if you send them all over there, it's gonna be equal to constant. Let's say for example, it's gonna be 12. So it's a constant, right? So that's what we did here. We make all the constant components in one side and the variable components on the other side. However, you can solve the problem, but it's gonna take much longer that you put all the pieces together. Oh, I'm gonna figure out what is the whole length of this rod. So it's this part, plus this part, plus this part, plus this part. So it's gonna take a very long time until to put all the pieces together. But all what I'm interested in when I take derivative. But when you take derivative of all the constant parts, it's gonna be 0. So why did I put them? So why I didn't put the variables parts only and make them equal to constant and just differentiate them? It's gonna give you the same solution. Like if you differentiate this, dl dt is gonna be 0. And then you have VB and dx4 dt is gonna be 0, 0, 0, 0, 0, 2VA. So you'll end up with VB plus 2V8 is equal to 0. Okay? You got it?
When you take the derivative in that first step, it's basically the same theory from position to velocity for the same velocity.
Yeah, but here you have two bodies. This one has a velocity and this one has a different velocity. So I differentiate the position y with respect to the time, so you are getting the velocity in the direction of y, not x. So we are talking only in one direction. So it's a linear motion, not 2D motion. Okay, so let's solve another problem so we can have a full grasp on this. But right now we are going to have two chords. But let me write here how you solve this problem. You solve dependent motion problems. Number one. Identify fixed data. Fixed data to measure the distance, and then get the variable lenses. And you get an equation something like dy1 plus dy2 is equal to a constant, something like what we did here. Then take the time derivative. Number two, take d dt to get the velocity equation. Number three, manipulate equations to find velocity. To find VA, VB, VC, whatever. Sometimes we're going to have two chords, so we're going to have two equations. So you are going to solve two equations and two unknowns and stuff like this. So let's see. All right, let's go here. So this equation has two chords. The first chord is connected like this. All right, so you have it coming from here, and then goes here, and then goes all the way around here. Okay, so this is the verse 1. The second one is from here, and goes all the way around here. And then you have a body here, and you have a body here. So let's say that this is B, and this is actually, it's called P. All right, so let's see how we can solve it using this 3 steps. Identify a fixed datum that doesn't move. So the fixed datum is actually this one. This one doesn't move. The center of all these poles. And then get the variable lenses. Where are the variable lenses? Okay, let's see what is moving here. This part can move up and down, right? And this pulley can move up and down, and this weight or this particle can move up and down, right? Okay, so let's put from Y1 to Y3. Let's see. So let's start with this one. This one is moving from here to here. Let's say that this is Y1, and this pulley is at here, and it's moving with Y2, and this pulley is here and is moving with Y3. So these are the moving parts. Watch out to the steps. Verse 1, identify fixed datum. I know that these points are fixed. These pulleys are fixed to the ceiling, are not moving, but this one is not fixed, can move up and down. You'll tell me, if I want to find the velocity of this body, why you are measuring from here? Why you don't measure from here? Because this one is connected to this one. If this one is moving with a velocity v1 meter per second, this body is going up 1 meter per second. They are connected together. But what I know is this chord. I don't know about this one. So I make them connected together. Okay, so I have Y3, Y2, Y1. Let's figure out how we can build the equations. Let's build this equation that connect the rods. So we need to find out each rod how can build an equation from it. So you can do this thing. You can say, okay, I have this rod, have this piece, and then this piece, and then this piece, and another piece, and another piece. However, I know that this piece is constant and this piece is constant. So the variable lenses are these two and this part. Okay? So let's work with the variable lenses. The verse equation is gonna be, you guys tell me, what is the verse equation is gonna be? I have these two moving pieces, 2y3, right? This part and this part. And this piece that I don't know what is the length, but I know y3, and I have a variable y2. So it's gonna be y3 minus y2. And this is equal constant. If you don't understand this and you wanna work with the whole length of this chord, name this as x1, this piece, and name this as x2, and say that the length is equal x1 plus x2 plus this equation. And differentiate L is gonna be 0, x1 is gonna be 0, x2 is gonna be 0, and you will end up with having this part, okay? But if you work your mind a little bit and only put the moving parts and make them as equal to constant, so it's gonna be much more easy. Okay, I built the verse equation. Let's say that this is constant 1. Let's get to the second chord, the green one. So the green one has actually multiple pieces. It has y2 and another y2 and another y2 and y1. So how many y2s? 3 y2 plus 1 y1. If you want to put the other pieces, you can name this x3, x4, x5, and you put the whole length of the chord and take the derivative. Okay? But I only put the moving bars and make them equal to constant. Okay?
So for Y2 and Y3, if they're both sharing a chord, like they're both sharing like the length, so
they are not. It's not. Well, it's not about they share the chord or not. It's about what is moving particle. So this is the moving particle and this is the moving particle, and I measure them from a datum that doesn't move. Okay, and then I figure out how to get lenses. So for example, this lens doesn't have a length of y3 and doesn't have a length of y2, but y3 minus y2 gives you this length. So it's the difference between them here. Okay, so that's what I did to get this length. Okay. All right. Okay. So what is given in this problem? I give you that this body is moving up. VB is moving up 1 meter per second up. So that's what's given in the problem. And I know that VB is V1. Okay. So I have these two equations. Let's put them in a better way. So you are gonna have 3y3 minus y2 is equal to constant, and you have 3y2 plus y1 is equal to constant 2. I differentiate this one, so it's gonna be 3 V3, so you differentiated d dt minus V2 is equal to 0, because when you differentiate the constant, it's going to be 0. You will do the same thing with this one, so you will end up with having 3V2 plus V1 is equal to 0. These are the two equations. I'm going to substitute with this one. I know that V1 is going up, so V1 equal to negative 1 meter per second. Why negative? Because I assume Y1 is going down, and I'm saying that VB is going up, so it's negative 1.
Professor, sorry, to follow, did you go back to where you get 3y2? No, the 3y2, I know it's the second
This one?
system.
Yeah,
It's the
so,
second.
so I have this one is going this way, this way, this way, and
Oh,
this way.
yeah, I missed, yeah.
So I have
missed that
1,
one. Yeah, yeah.
2, and 3B.
Yeah, got it.
Perfect.
Professor, can you go again why it's negative 1 meters per second?
Okay, so given in this problem, it says that this weight is moving up, whereas 1 meter per second squared. However, I assume that y1 is going down. So this is in the opposite direction, so I put it as negative 1.
Oh.
If you want to put y1 is going up and everyone is going up, and it changed
Then it's
direction,
positive.
it's up to you. Like you can do this. It's based on what is your assumption is. I assume that the positive is going down, but this is going up, so the up is gonna be negative. Alright, so let's substitute. V1 is negative 1, so right now I can get V2 is gonna be equal to, this is negative 1, I'm gonna send it the other way, it's gonna be 1 over 3 and meter per second, and it's positive. That means that V2 is going, if it's positive, V2 is going down or up?
Down.
Down, so this one is gonna go down. Either this is positive, that means that it's in the same direction of y2. So let's get V3. So 3V3 is equal to minus negative V2 is equal to 0, so you will have 3V3 is equal to V2, and if you divide by 3, it's gonna be something like this. So you have 1 over 3 over 3, so it's gonna be 1 over 9, and it's positive meter per second. So this one still goes down. This is V2, and this is V3. And actually that makes sense. If this one is going up, so all this length is gonna roll, and this one is gonna go down, and this one also is gonna go down a little bit, okay? So this one is gonna go with bigger rate, 1 over 3, and this one is gonna go down with less rate, is 1 over 9, okay? So, yeah, that means my assumption is correct, yeah. So, if I assume, like, no, it's positive because I assume this one is like the directions, but actually you can do the opposite. Like you can say that y3 is measured from here to here, but this is going to be confusing. We always measure from a fixed thing that doesn't move. So this doesn't move, and I measure from it, and then I go down. So y3 is measured from here going down, so that means that this is my positive direction. If you, for example, if you change it once, like let's say that you said I'm gonna make this up positive. So y1 is gonna go up, and this is my positive direction. So you are gonna keep this one positive, not negative, not the way that I put it. It's gonna be the same thing. Okay. Alright, does anyone have any questions so far? So I solved some, like 3 other problems here, and the textbook has some solved problems. This is an easy problem, okay? Like this one is an easy question. Next time there will be a quiz
Do you know what I'm saying?
up to the stuff that we taken up to this lecture, okay? But maybe I'm gonna give you the quiz on this system. How about that? Like, let's not you guys study the Cartesian, curvilinear, like tangent normal. This one is a little bit easy. So I'm gonna give you the quiz next time, like next on Thursday. It's gonna be on this part. It's very easy. You don't have like just linear equation. You know how you should be able to build a linear equation. And it's gonna be the same thing. The exam is gonna open at 12, and at 12 you can take it at any time. But there will be multiple questions, so everyone might get different question from each other with different numbers. Alright?